Okay, so this is first thing, it's a tangent double, or no, sorry, it's a tangent sum formula, okay? Because what they're doing here is that they are implying right here a particular angle, okay? Here they are implying a second particular angle, okay? Now, because they are doing that in terms of x and y, the angle is going to be a general angle. It's not a specific angle, okay? So I'm not going to know that it's 35 degrees or something like that. But when they say sine inverse of x, think about the sine inverse function does, okay? This x is an input that is a ratio of opposite divided by hypotenuse, right? This output is an angle, okay? And for us, it'll be an angle because the way that we understand the sine inverse to be defined between -1 and +1, if I put values between -1 and +1, the only thing that will ever come out is something between -90 and +90. Okay, I probably should use x there instead of theta. Does that kind of make sense? What quadrant is -90 and +90, or what quadrants does that talk about? First and fourth. Okay, so when I draw, so we have to draw a picture with these, or at least I think that's the best thing to do to organize your ideas. Because we know the sine inverse is only going to work in the first or fourth quadrants because of the condition we just talked about right there. We have to decide, do I draw my triangle in the first quadrant or do I draw it in the fourth quadrant? Okay? Well, this ratio right here tells you. Remember, this is a ratio, which this is where I think it gets people confused because it's not written as a ratio, right? What is the denominator in that ratio? 1, okay? So this ratio of opposite side divided by hypotenuse, the opposite side is x, the hypotenuse is 1. And because of the signs here, that's IGN, those are both positives. The only way that I could do opposite divided by hypotenuse and abide by the conditions of the sine inverse is if my triangle existed in the first quadrant. Because x is the opposite side, and that has to be positive, right? The hypotenuse is always a positive number. So that's what we get. That's the picture that we're getting there from what we have written in green. Does that make sense? Now that we have that, we can find this distance here by using the Pythagorean theorem. Okay, so that will end up being, what, 1 minus x squared underneath the root? Okay. Now, that gives us an arbitrary ratio of some x value. Does that make sense? Now, we know because the sine inverse that x value can only come between -1 and +1. What that arbitrary x value does now is creates this arbitrary angle right there. Because I don't know how big x was. Okay. Now, I do know that because it's positive, it's no longer between -1 and 1, but it's between 0 and 1. So I don't know if x was that distance, or maybe x goes right there. So then I'd be looking at an angle that's a little bit smaller, right? Or maybe x is a larger value, so maybe x is up there, so the angle would be a little bit greater, okay? So I don't know what this angle is. It's arbitrary. So if it's arbitrary, I'm just going to call it theta. Is it okay? So sine inverse of x is the output is going to be theta, but all of this stuff here is attached to that theta. Okay? Now I'm going to do the same thing for the blue. But now the blue is referring to a different angle, right? What quadrants is the cosine inverse defined for? First and second. So our input for the ratio is now adjacent divided by hypotenuse. And because of that, we know we should use -1 to 1. Those are my input values. And the output, though, is going to happen because of how the sine inverse function operates. If I put -1 in, I'm going to get 0 back. Okay. If I put +1 in, if I put -1 in, I'm actually going to get 180 back. If I put +1 in, I'm going to get 0 back, right? So everything in between is going to be between 180 and 0 degrees. So I know we're going to operate in the first or second quadrant. Okay. Now, the adjacent side is y, the hypotenuse is 1. So what quadrant then, based on this condition and the condition of the cosine inverse being first and second quadrant, what quadrant should my picture be in? It should be in the first quadrant. Because now, the only way that it could be in a second is if this y value was what? Negative. Then over here, when we did theta, the only way it could be in the fourth quadrant is if that x value was negative. So that's y, and this is 1. So the Pythagorean theorem will tell me that this is 1 minus y squared. Again, y is arbitrary. Y could be between, in this case now, 0 and 1. Okay? So if this distance was here, okay, and this was 1, what that would actually, so the hypotenuse would have to stay 1, the angle would be more like that. Okay, so I'm getting a different angle here depending on how big y is. Does that make sense? I don't know what that angle is. It's arbitrary, so let's call it phi. And you can use any letter. You want to use alpha and beta, you want to use a and b, you want to use x. I would stay away from using x and y, and I think that's why this question maybe is problematic for some people. Because they do use x and y, and if I look at this, I just think people get confused because, well, this is using my x-axis, and they're saying that this value here is x, and that's just the nature of the question. Does that confuse people? The locations of x's and y's based on these and based on comparing that to the x and y axes? Okay. So now if I look at this, replace the green thing, sine inverse of x, with theta, I now have tangent of theta, and we'll replace the blue with phi. So I get now tangent of the sum of two angles, right? Which to me, I know that formula. I'm going to say that you guys probably don't know that from heart, which is fine. I'm not making you memorize these formulas. So you would then reference back to your reference sheet or whatever, and you find out that the tangent of two angles being added together is the tangent of the first angle plus the tangent of the second angle divided by 1 minus the tangent of the first angle times the tangent of the second angle. That's the tangent sum formula. Okay. Now, and this is why we had to find these third distances on these triangles. If I ask you what's the tangent of theta, you can now look at this picture, and you know the opposite and adjacent sides, right? For theta. Remember, this angle right here is theta. You've got the opposite side being x, and the adjacent side being root 1 minus x squared. Add to that the tangent of phi, which would be root 1 minus y squared over y. The denominator then becomes 1 minus the product of those two things now, right? So something like that. Okay. Now, the last class also asked about this question, and I told them I do not know what WebAssign is going to do if I type that in. They might say, yes, this is fine, we'll accept it, 100% credit. They've done that in previous assignments where they don't require complete simplification. But they also have certain situations where they do require complete simplification. Okay, so let's go ahead and completely simplify this. If I want to completely simplify this, right now this is a a compound fraction. Okay. I want to take the numerator. I'm just going to focus on that numerator, and I want to write that as one fraction, one ratio. So what do I need if I'm going to do that? Common denominator. So that common denominator is just, and I would try to, in all instances of trying to simplify things like this, find the LCD, the least common denominator. So it's just those two things multiplied together, right? So I need to multiply this by y over y. So it gives me xy over then y root 1 minus x squared. Over here, I need to multiply by the root of 1 minus x squared, right? On top and bottom. So it's going to give me plus then root 1 minus y squared times root 1 minus x squared all over y times root 1 minus x squared. So that's the numerator, and we can do a little bit more work with that. Let's go. Come on. There we go. Now, and the purpose of doing that was not because we said we wanted this to be one ratio, and when I create that LCD, I'm deliberate, and I don't try to do everything in my head. I don't try to multiply and find each one of these numerators and add them together at the same time. You can, but that's going to eventually lead to this. That kind of make sense? Okay. Now let's go target the denominator. So the denominator is 1 minus this product. So I'm going to work with the product real quick. The product is x root 1 minus y squared over y times root 1 minus x squared, right? And it's 1 minus that. So I'm just going to, if this is going to be, or if we're going to go 1 minus this, let's put this 1 in terms of this denominator. So it would be y over root 1 minus x squared over y root 1 minus x squared. Everybody okay with that? And then we will have y root 1 minus x squared minus x root 1 minus y squared. So that's combining these two numerators. And this denominator is y root 1 minus x squared. What do you recognize about this denominator and that denominator? They're the same. So when they're the same, because of how we solve compound fractions, we would multiply by this one's reciprocal, right? What that's going to do is effectively just cancel those out and leave you with this numerator over that numerator, but this numerator then becomes the denominator of my answer, right? So I then get xy plus 1 minus y squared root 1 minus x squared all over y root 1 minus x squared minus x root 1 minus y squared. Nasty, right? Okay, but let's look at this thing graph real quick. So we started with tangent of sine inverse of x plus cosine inverse of y. Okay, now if I wanted to actually graph this, we hit y equals, graph it. Okay, so that's it. Then, if I want to do this with pure algebra, so let's go see if we can type this thing in real quick. So we got xy plus the square root of 1 minus y squared times in the square root of 1 minus x squared. Put all that over y times the square root of 1 minus x squared minus then x square root of 1 minus y squared. Okay, now it's going to bulk at that because we got x's and y's, and if that's the case, you've got an implicit equation, then you got to say, in this case, y equals, and what do we see? They're the same, right? Okay. So I don't know what you think. When I look at this visually, that looks more complex than what I started with, right? But the nice thing about this is that if I'm going to use a computer program to maybe generate this value for whatever reason, my computer program now doesn't have to know anything about tangent, sine, and cosine. It can just use x's and y's and products between those and adding, subtracting, multiplying, dividing. Okay, which most of your like your JavaScript, your HTML, that kind of stuff that you use for coding, that's the foundation of it, is your order of operations and that kind of stuff. Does that make sense? Okay. If you wanted to, you could say, well, what if, because this is going to be a ratio, what if I choose like 0.5 and 0.5 here, and then come back through here and put 0.5 through all of those? I'm not going to do that, but it should give you the same number. Is that okay? Pretty lengthy problem. Not going to give you one that difficult on like a test in class, like it's going to take a lot of time to do. What stinks is all that work, and I get this. I've been in many classes where you are graded basically on an input box. You could do a lot of that work being right, and maybe at the end you put in the wrong plus sign or minus sign. Because if I did everything there technically right, but maybe my double or my sum formula for tangent, maybe I wrote it as tangent of theta minus tangent of phi over 1 plus tangent of theta tangent of phi. So I used the wrong tangent sum formula. But structurally, procedurally, I did everything else 100% right. I'm not going to get credit for it because I'm just typing into a box. If you did that on a handwritten test, I'd probably circle it, say be careful, and give you full credit. Okay. So I get frustrated. I understand you might be like, dude, that's a lot of work for a 1 point, 2 point question. Understand that that's not really the 2 points or 1 point is not the purpose of the assignment. The assignment is to understand that concept so we can use it later on. We cool with that? It's only one question, and that took up the whole period. If on Monday you guys have more questions about anything that we're covering or have been covering, please let me know, or if you want to shoot me an email and I can lead you in the right direction on some of this stuff, please do that. I don't know if I said at the beginning of class, but I messed up the assignment 7.4 and the due date. I actually messed up the gym and didn't catch it this time. I usually forget, maybe I schedule it for you guys, maybe that's why I didn't catch it, but I forgot to schedule it to all the courses. So it wasn't populating for everybody. So that's going to be moved back to, I think I got it open like till Tuesday or Wednesday. So just be working on that. And if you got any questions on that, let me know.